by now, you have this in your calculator already. So it looks something like that. And you're like, oh, that looks pretty straight. And if you go to the regression, you can get the model. And there's a way to get, I can never remember what it is. Oh, hang on. There we go. Nope. There's a way to get it to show you I thought, and I can never remember what it is, to show you what the model is on this screen. Oh, there it is. Okay. So that's the model. Everybody good with finding the model?
Oh, wait, I got it.
Yeah, I don't know what the sequence is. You lied?
I got it.
Okay. Bam, 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 bam. Were you what, the Flintstones?
Oh, I got it.
All right. So we've got our model. And then it wants you to discuss the appropriateness of the model. And if all you do is look at the line of best fit and the scatter plot, you may think it's perfectly good, but you'd be wrong. Yeah, you always need to look at a residual plot. So on this, if I go back to regression and I look at the residual plot, uh-oh.
Goodness.
The residual very much has a curve in it. So that means that this is really not appropriate. Okay, so if you haven't already written that down on your paper, write down, because the residual plot has a definite curve to it, when it should be just random scatter, a linear regression is not appropriate.
Why, if the residual plot is the only different thing, is a linear model not appropriate?
So what this particular one shows is that for small input values, the residuals are positive. In the middle, though, the residuals are all negative. So that means it doesn't actually pick very well, right? We'd like it to be some above, some below.
So this one's saying that like for extrapolation, we wouldn't want
No.
just in general.
Yeah, the problem is if you picked like 22, it's going to give you a number that's too low, and we already know that. Or if you pick something out here, your residual is going to be positive. We shouldn't know which way the residual is going to be in advance of actually putting it in. Right? That's why we want that to be random looking.
Because then any of the numbers in between could be anything.
Yeah. But we pretty much know that anything between 10 and 35, that our residual is going to be negative. We shouldn't know that, and they shouldn't all be negative in a row like that. Okay, so that's what the problem is here.
If the residual plot was all positive, but they were random, it's still good.
If the residual plot is all positive, you've done something wrong.
Alright, good to know. Hey,
Right, that means your data was up here and your line was down here. That's no good. All right. So now we want to do something with this data. So there are all kinds of different possibilities. Well, find mine, find what it is that I did.
Hey Shepherd, can you talk to me? You need to quiet down. I'm trying to learn. I'm in class right now. Just trying to learn.
Hey. That is even.
So let's try a couple of things. What's something we could try? Well, we could try to take the logarithm of these numbers, and let's use the natural log. Okay? What? So we're going to take the natural log of the population. So of our output variable. So I'm going to go back to my data. And take the natural log of each one of those. I don't remember what that number was. There we go. What?
There's been a day distributions.
I'm so sorry, Mr. Lucas.
So I'm going to tell this to do a linear regression. I think it's already done it. And let's look at the residual plot.
It's unfortunate.
Is it better than it was?
Yeah, it's got two curves.
It's better than it was, but maybe not great yet. Now, the other thing that we could have done to compare is look at R squared.
It's kind of the same.
Did you look at the R squared for the original one?
I thought it was also 0.99.
Yeah.
So it's difficult to tell if that's much better. Okay, and again, you could spend quite a long time doing this. Okay, is this a little better? Yes. Is there, some problems with the residual plot? Yes. But the other thing I notice on this is that the residual plot numbers are really small. You have a very small residual, which means it's fairly close to predicting with accuracy. Okay? So, not going to spend more time trying to get a new one on that. Let's use this model to predict the population from the year when Mr. Davis was born,
1990.
1962, back while the Earth was still cooling.
That was good. Almost like Shepard.
Why did you say that, Jackson?
So what we know
Yes, I am.
is that the natural log of the population
Oh, we're already done.
is equal to, if I have the numbers written down right, is it negative 27.08 something? Have a banana, Mr. Davis. Why, thank you. I think I will.
Yes, Mr. Davis. Yes, you should.
All right, so, oh,
Wait, 0.017?
sorry, I was looking at the wrong one.
I think it's plus 7.8.
So what was it?
0.0179.
0.0179, thank you. Times the year since 1950, right?
Since 1950, yes. Years since 1950.
And then what was the intercept?
7.8428.
So we're going to put in what for this?
5.
12.
Oh, goodness.
Wow.
Goodness.
12?
Wow.
Goodness. I didn't mean to say that. Alright. You can calm down, Leon.
Wow, 5?
I will
I
it.
think you have to take a lap for that one.
And I will blame it on Samar.
My other extra desserts.
Yeah.
They're running away from the problem.
But what we can do is we can just move this to 12. And it gives us 8.05777.
That's so smart.
That's why I get the big bucks.
Yes, Mr. Well,
But we need to get it back out of the natural log, so it's going to be e to that power.
Oh, that's what it's for.
how do you get down to your points?
So that'll be e raised to the 8.0.
I have to pass Mr.
Back
Davis.
so soon.
Yes. Or you can just walk into that one.
Are you sure? It says closed for maintenance.
Yeah.
Why is it flat?
Wait, Mr. Davis, question. How did you get to navigate to 12x so easy?
When you go down,
Oh, there we go. I didn't start working right now. Yeah, thank you, Jackson. Jackson the goat. Jackson, my goat.
So when you do that, you should get
You gotta go to the thing. You gotta
Why is she crying? You gotta go with the thing.
3158.26. The actual for this was 3126.7.
Can you show the
Can I show the what?
the process behind that?
The what?
The process.
I just did.
I know, I don't know how I missed it.
Okay. So do you understand how I got the 8.05777?
Yes. And down the
Do e to that, because that's what undoes natural log.
And that's where the numbers come in.
Yep.
Alright, so sounds
how
good.
did you get the actual value for this one?
Jackson.
I looked it up.
Oh, okay.
Yeah. Now, if you estimate the population in 2010, so what is that?
Right.
What year is that?
60.
So put in 60. and you get 8.9175. So e to the 8.9175.
Got 7462.16-ish.
Yeah, depending on how many decimal places you put in, you get 7461. The actual on that was less than 7,000 million, so less than 7 billion.
That's a lot of billions.
Yes. So when we're doing that, what is it that we're doing when we're estimating the population in 2010? We're extrapolating. We're going beyond what's inside of our data set. So that's always suspect. All right, we don't know. And then F, can you use this model to estimate when the population was 4.5 billion?
Yeah. Stop.
Pardon?
You could,
Yes.
right?
Mr. Davis, they were a few billions off from.
This model only predicts the population from the year. Although the equation, you can substitute it in the other way, but remember, we cannot use our model backwards.
Oh.
It predicts population from years. It will not predict year from population.
Probably 1981.
All right, let's move on.
Why are you shaking
All right, try this next one. See if you can do parts A and B. Oh, and for the last entry, do you have 29.7 or 19.7?
29.
Okay, I have fixed that then. Just wanted to make sure. So have you got your scatter plot yet? Is the scatter plot very straight?
No.
No. Right? The scatter plot kind of looks like a parabola or the beginnings of one, right?
Yes. This parable.
Kind of has this bend upwards. Okay. So to undo that, what might be appropriate?
Squaring the data.
Well, it's if it looks like this, it's because it was squared.
Square root.
So maybe taking the square root. Now, let's save ourselves some time. When you are putting those things in, I didn't put the data in here, I just left what I had. But let me show you something. If you don't want to have to completely redo your data, you don't have to. So what I'm going to do is I'm going to go up here to X2 and hit EXE, and I want to fill that with a formula. And they have all these different choices here. The one that I really want it to just be X1, right? I want to keep that data. I usually go down here and pick this one and then just back over it. And it automatically fills that with what was in X1 without you having to retype. Like on the last one where we're having to put in natural log for all of them and retyping all that, it takes a while. And then for Y2, I'm going to go, okay, I want to fill that with a formula. And I don't really want this sum. What I want is the square root of Y1. So let's go back and put in, do the square root of Y1.
That is a good key.
Well,
And it'll automatically fill those. And again, my numbers are different than what you should have. So I'm going to do that on my calculator.
Pretty cool.
And you'll notice you get a new regression or your new scatter plot that's much lower than the original one. It's a little bit hard to see. I am going to see if I change that to auto. Does that help? Not really. So now when you go to regression, you have a choice, X1, Y1, or X2, Y2. And then you can pick a linear model for that and see how good it is. And then again, if you go to regression, you can look at the model. You can also look at R squared. You can also look at the residual plot, which isn't great, but it's better than it was. Okay? Yes? So remember that it's automatically going to make a list of all residual. You just have to put that in L whatever. Right. So what you can do is go to stat, edit, and put whatever, wherever you want that residual one to be.
It's not cinema.
McDonald's for lunch?
Why did we even know that?
Don't go to local meetings. Like, you're not supposed to.
Oh.
Now that practice today, Jackson? You have practice today? Yeah.
Locked in? Oh. Where is this from?
Not that I know of. Y'all have a great day. Bye-bye.
No.
You did not run here, guys. Yeah, I actually sprint here every day. I just love Mr. Davis.
Well, that's nice to hear.